Hello, hi everyone. Good evening. Hope you guys can hear me right. If you can hear me, just give me a thumbs up or yes in the comment section. Okay, great. So, welcome everyone to the fifth professional masterclass of the Gemini Academy. Right now, you must know what is all about this program is. What is the Gemini Exchange program? What is Gemini Academy, and what is coming up in the future? But for the new folks, I'll just give a small brief of what's going over here. Gemini Exchange is a program which brought to upskill Indian developers prominently in generative AI. It runs in two phases, Gemini Academy, and then later on there will be hackathon phase as well. So in Gemini Academy, you'll be getting hands-on with 5 courses. Usually these courses requires you to buy some credits to complete them. But under this program, you'll be getting those credits at free of cost where you can complete these courses. To get these credits, there are some small ways which you have to do. So you will get the credits to learn for the remaining courses. I will just give you a small brief of what have to be done after registering to get this courses credits. So once you register and you will be landing upon your hackathon dashboard, I'll just present my screen for my hackathon dashboard. Yes. So this is your hackathon dashboard. Once you register, you'll be landing over here. And you can see there are multiple sections over here, the roadmap, social media submission, and skill boost and skill bash submission. If you come to skill boost and skill bash submission, you can see a place where you have to give your Google Cloud Skill Boost public profile link. So it's the very first step. So once you register, you'll be registering on the same email address on the Google Cloud Skill Boost profile link as well. And you will be getting your profile link and make all sure the public profile link is always public. Once you register here, you also register on the Google Cloud Skills Boost platform and you'll be getting a profile link, which you have to make it public and submit over here. So while submitting, you need to enter your registered mail address and as well as a Google Cloud Skill Boost public profile link. Just make sure the profile link is always set to public, don't change to private. And the second step is complete 2 free courses. As I say, there are 5 courses on this Gemini Academy. There are 2 free courses in this as well. One is prompt design in Vertex AI. The another one is build real world AI application with Gemini and Imagine. These are so easy courses that you can complete and it's beginner friendly as well. So once you complete these courses, you'll be getting a badge as well in your Google Cloud Skill Boost public profile account. So you need to enter your email address along with the badge link. So once you submit these 2 courses, badge link along with the email address, somewhere between 8 to 10 business days, you'll be getting credits where you can use those credits to complete the remaining 3 courses. But make sure the initial steps are always followed. Register for the hackathon, make sure your Google Cloud Skill Boost public link is always public, and you complete the 2 free courses and submit the skill badges as well. So once you've done all this from 8 to 10 business days, you'll be getting credits where you can progress through a journey. So that's on this thing. And as you know, the numbers are always going to be high and the developer communities never fail to impress us when there is a program like this. And right now we are standing at 247,000 developers who have already enrolled for this program, and they have started their journey as well. If you're not one among them, I would suggest you to start your journey today itself. It's late is always better than never, right? So if not today, start it tomorrow, I would say, but don't make it more than tomorrow. Every day you're getting new and new courses coming in, and there have been a lot of things for the people who enroll over here, and I would say don't miss this opportunity. And what's in it, apart from learning, I would say learning is the main thing, but apart from learning, there are a lot of things which you can take away from this program. The first thing is you'll be getting skill badges for the courses you complete, which you can obviously showcase in your LinkedIn, in your profiles, in your CVs and curriculums, etc., etc. And if you complete all the 5 skill badges given on the dashboard platform dashboard, you'll be getting an Gemini Academy completion certificate. So once you complete all the 5 courses, you'll be getting an academy certification as well. And there is a leaderboard is something I would like personally, because ranks is always good from school days. So there is a leaderboard and there are a lot of things which decide this leaderboard, which is nothing but the points, and I will be in the next slide. So what happens if you top the leaderboard? There are a lot of things: Google in-person event invites, exclusive Google merchandise, and there are many more. And the last and the best thing, learn from the best in the industry experts. You're gonna get insight from the industry experts. Not only gonna run through some rules and regulations given a document. It's gonna be a master classes. There will be lots of hands-on sessions. There can be boot camps where you can learn directly from the industry experts itself. So leaderboard, as I said, leaderboard is something personally I would like. Everybody would like that basically. And what are the points in this leaderboard? The first thing is the big one: 100 points on completion of each course. As I said, there are 5 courses, and completing on each course and submitting the skill badges, you'll be getting 100 points. And attending live masterclass will give you 20 points. And if you watch a pre-recorded session, like this is a masterclass, after this masterclass ends, if you watch it as a recorded masterclass, you'll be getting 10 points. And there is a two sections, which is a very really good one, which is nothing but handling over to social media. You'll be getting 30 points for posting a blog on Medium and 10 points for posting a skill badge on LinkedIn. I'll just show you where you can post those things. So in this team dashboard, if you go to social media submission, you can see there are multiple submissions available over here. Say for example, I have completed prompt design in Vertex AI. I'm just selected that skill badge, and I just gonna give my enter email address, and I'm gonna post a link along. I'm gonna post a post in LinkedIn along with the skill badge which I got right now. So in this case, I got prompt design Vertex AI. I gonna post a picture of this prompt design Vertex AI in the LinkedIn, and I gonna give the link to the post over here. And you can write a blog over in the blog Medium and give the same link over here as well. So these things are just given you for the leaderboards, and these things are always great if you take it in a good way. And there is always an option to explore and learn in any program. And this, I would say, personally, a biggest program running throughout the India. And I would say, if you're not a part of it, just come in and just give it a try, and let's see what it takes and whatever it takes. That's all I have for you today. And this masterclass might require you some credits if you didn't got credits at. So please do listen to the masterclass. Just grasp the points take away from the experts, and later whenever you get credits, you can use those learnings over there. If you don't have credits, not an issue. You can go through the masterclass full and fully. If you have credits, if you want to perform the lab side by side, you are more than welcome to do it. With that, I would like to welcome the speaker for our today's masterclass, Sanskriti, who is a custom engineer at Google Cloud. Yeah, you're on mute, Sanskriti.
Sorry, my bad. Yeah, thanks, Ganesh, for the introduction. Can everyone see my screen?
Yes.
Yeah, all right. As Ganesh said, I'm a customer engineer in Google Cloud. I primarily work with startups and digital natives to sort of help them not just with their migration journey to cloud, but also one step beyond on how do we integrate AI in the best way to sort of make our workflows efficient and our solutions a lot more impactful, right? So while you have already had 4 classes before this, and I think if you have attended that, you already have a sense of what Gemini is. But just a quick recap: Gemini is our multimodal generative AI model. The latest version of that being Gemini 2.5 Pro and Flash. When I say multimodal, what I mean is this model is not just trained on textual data, but it is also capable of understanding code, images, documents, which means PDF files, audio, video, all of that entire sort of uh, types of data inputs, right? So, along with your prompt, which will be textual, you can also actually key in an image, you can key in uh, documents, video, all of it, right? And you can have a mix and match of this according to your use case. So that's what Gemini is. Now, in terms of our model families, the latest one is 2.5 Pro. It's also topping charts in coding and complex sort of use cases in LM Arena. And other than that, in the latest models, we have 2.0 Flash, 2.0 Thinking, and 2.0 Flashlight. Just a few things to note here. When we say 2.0 Flash Thinking, the idea is that in a thinking model, you also get the thought process behind the LLM response, right? So it's not just going to give you an LLM response, but it's also going to say that, hey, this was my thought process behind it. This is my sort of mind map, and this is how I've come to the answer. Now, this is not always necessary for a use case. So you can actually have a thinking budget where you can say that, hey, I don't want it to tell me how it thought about these things because that's going to add to my cost. So I just want the direct output. So depending on the use case, customers sort of work with different versions of our models. The thing to highlight for today's session are two components, right? Which is multimodality, which is native to this model. So gone are the days where we're training a model for image understanding, for video understanding separately, right? We have models now capable of that. So one is native multimodality and one is the long context window. Now, why does a context window become important? Because while LLMs have knowledge from worldly data, they've been trained on data from the internet, but you always need some contextual data based on your businesses, and that could be very enterprise focused, very domain specific, and that is not going to come necessarily from an external entity, which is where we need to have a larger context. And this is the thought process we are looking at when we are looking at solutions like RAG as well, and we'll cover that in detail. So with Gemini, we are going with up to 2 million token context windows, which is really, really large. Now, to put things into perspective, 2 million token count would mean 2 hours of video, right, which can be processed by an LLM, 22 hours of audio. And I mean, in terms of lines of code, if you want to plug in your entire repository, and this becomes a lot more useful when we're looking at use cases like coding agents, right? You can't just put a single file and expect it to understand your enterprise code base. So, this is where a token window becomes very important. Uh, what's new with Gemini 2.0, which is sort of come into picture now. I think if you have worked with our models before, there was 1.5, and what's new with 2.0 is, of course, it's a faster model with higher quality. In with respect to 1.5, it has two output modalities. So not only not only text, which was initially there, we're also able to output speech and image, right? Then we have native tool use, which means how do I connect to either an API or how do I run a piece of code along with this LLM prompt, right? That is where tool usage comes in. We have multimodal live API. Now, what live API does is you can stream in data into the system. And then I already covered what the thinking model means, right? Which generates the thinking process of the model as part of the output, which gives you a lot more reasoning capabilities. So jumping into what are LLMs being used for? 1 year before this, or like not even 1 year, maybe 1.5 year, 2 years before this, LLMs were just a black box or a model we're using. They've been pre-trained on a lot of publicly available data, and they can generate text, can summarize for you, answer questions based on your query itself, right? Now, this is not necessarily going to be enough. uh, for example, let's say I ask a question saying what is langchain, right? 2 years, 3 years back, langchain didn't actually have a meaning. So it would simply say that, hey, langchain is a blockchain based platform, right? Now that's completely wrong. So to be able to not hallucinate, sometimes we need to pass contextual information, which is more new. Either it could be more latest data because the model is trained maybe 1 month back, maybe 2 months back, or it could be data which is enterprise specific, right? So, how do we best augment our LLMs with our own data? Our data could be unstructured data, which is PDFs, documents, images, videos. It could be APIs. So, you as a enterprise business would have designed APIs, right? How do I pull in data from my API endpoints and actually pass that into the LLM for context? It could be your databases, which is structured, unstructured, your vector databases, all of that. It could be files, and it could also be your enterprise systems, right? For enterprise systems, for example, let's say you want to build a solution which uh, sort of is an agent on top of your Salesforce CRM, right? So in that case, I need to connect to Salesforce as an enterprise solution. So how do we build those connectors in? So these are different sort of sources where we want to ideally pull data from. Now, what are ways where we can make LLM models answer based on our own data, which is private? One is you do a full fine tuning, which is you retrain the model or retrain a base model, baking in your knowledge, changing the weights, the entire process of building a model, right? Or fine tuning an entire model. Now, why is this a challenge? You have to prepare the data, of course. It's extremely expensive, compute heavy, not necessarily for every use case would you have the budget to allocate or the resources to allocate for this kind of full-fledged fine tuning, right? It also means that when new data comes in, you again want to fine tune it, again want to retrain it. And even with all of this fine tuning, if you don't have the right ML team on board, or you don't have the right skills, you still may not be able to work, right? And your model might not be able to perform effectively. The second is a human in loop sort of solution where you put a human in between the output of the LLM and the user. Now, this works This is very dated. It will not always work in every use case because one, it's latent. There's a lot of latency which will get added, and also it's expensive because you're actually having a human resource in between, right? Also with humans, the tendency is that at times we become inattentive, we get distracted, and we can have human errors. So, all right, this is an option, but not the best. Then we have prompt engineering, right? In my prompt, can I pass all the context? Now, while we boast a 2 million context, or models even in open source are increasing their token count, it's still limited in some way, right? So you can't, if I have 20,000 PDF files which I need to plug in, I might not be able to do that with these token windows which are there. So while I have this option, that it is limited by tokens, right? And when I pass 20,000 files, if I'm able to, then for the model to understand that out of this what is relevant is also very difficult. So it might again throw out junk data, get confused. So there's a trade off between the performance, the latency, and also the cost, because with so much data getting passed in every prompt, you are going to obviously pay for that token input, right? So while these options are there, they are not probably going to work for my use case. Uh, so that's where retrieval augmented generation comes. We'll focus on the term itself. So when we say retrieval, we mean how can I retrieve relevant data from my data corpus? So when I had those 20,000 files, only maybe one of those files are relevant to the query my end user asked, right? So how do I retrieve that one file? Augment is how do I now take that data from that file and augment it into my prompt. So now I'm making use of that context window, but instead of passing 20,000 files, I'm passing one file. And third is, using all of this information, how do I generate an answer? So if you look at the diagram as well, what we're doing now is we have an input prompt, we have a retriever model, which will actually throw the question back to our information retrieval system, and it will return back related context. So not all of the data, but what is relevant to your question. And then it's going to pass that to the text generation model, which is your LLM. Uh, so now, because of this, we are able to tackle the problems which we had initially, right? Where LLMs didn't know domain specific data, LLMs didn't have real time information, and providing citations was difficult. But because now we have the data source as well, we can easily say that, hey, this is what I think the answer to your query is, and this is the data I cited my answer on, right? So what you're doing basically is you're feeding to the LLM relevant context in real time by using this whole information retrieval system. This is part of a larger picture of moving towards agentic systems. So this is what we are discussing in brief, but we are maybe 5 or 10 steps ahead of this, right? Where once we understand how RAG works, we can actually plug in actions, which is where I said you can make calls to we can make API calls, or we can connect to other agentic workflows. We can have a reasoning loop, and then we can have a multi-agent sort of system, right? Today we'll focus more on how do we work on with private enterprise data and plug that in into our LLM. So this is the phase we are sort of focusing on today. So now what happens is your modified prompt is not just the question you're asking, but also the retrieved information which you got from your backend system or your data corpus and the question itself, right? So this is how a modified prompt looks like, where you're passing in the relevant data which you have now identified because of this. Now we move to how do we actually do this, right? So first discussing how does classic information retrieval work. The idea is that we have a document corpus, we are indexing that document corpus, and based on the search query from the user, we find the relevant information. We search for the relevant information, and we pass it in as retrieved documents to our LLM itself. So there are two steps in an information retrieval system. One is retrieval itself, and one is ranking, right? And ranking will be based on the relevance score. So how relevant is a certain data to your end user query? So based on that, it's going to return relevant data. For example, let's say the use case is that I'm building a search, image based search for a, and this is one of the use cases in the labs as well, but I'm building a image based search for a retail platform, right? And a lot of retail platforms, you would have seen this, and this is actually how it's been built, where I take a picture of a dress, for example, I upload it, and it finds similar dresses, right? So how is it doing that? It's checking my query being this image input which I've given, and it's saying that, hey, out of the 100 dresses I have on my platform, what matches this the most, right? And this is a semantic match. So it's not looking for keywords or anything. It's actually looking for the semantic match between these two entities. Now, how is that actually being done? Uh, what we are doing in the backend is representing our data as uh, embeddings. Embeddings is basically a vector in mathematical terms, which translates multi-dimensional data inputs into embeddings, right? Which are lower in dimension, and it's also standardizing it, right? So even if it's text, even if it's image, my models now are getting a single type of entity which they need to understand, which are embeddings. So if you look at and if you go back to mathematical concepts, where we have learnt about a three-dimensional vector space, right? Where if there are two vectors, and we've learned things like cosine similarity in either university or school, right, in maths, where if two vectors are close to each other in a vector space, then their cosine similarity will be more, or their distance in that vector space between them will be less. For example, two music files will be closer to each other in the vector space than data related to a person, right? So that is the idea. So semantically similar inputs are close together in the embedding space or the vector space. So first step in any RAG solution is I need to convert my data into embeddings, so it can so I can do this comparison between my input query, which is the question the user asks, to all the data I have in my backend, right? To do that, to make them comparable, we need to convert it into an embedding. Once we have that in place, and just to follow up on that, we can do this now for both text and multimodal systems, which is images. Google Cloud provides models for text embedding, which is text embedding. The latest version is called 005. And then we have multimodal embeddings as well, which is works for text, images, and it's also getting incorporated into video, audio, all of that, right? Where we're taking input and we're converting it into embeddings. Uh, and this is how a sample code looks like. I mean, this is something you'll understand when you do the lab, but the idea in today's session is just to be able to familiarize yourselves with the concept behind it. So once we have these embeddings in place, how do we search across this embedding space, right? Now we have a product called Vector Search, which is a sort of search solution we have built, which can take an embedding, which can take in your data sources, take in your embeddings for them. So what you're going to do now is you're going to take your data sources, you're going to create embeddings out of it using the embedding model which I just discussed. Then what it's going to do is you're going to plug in all of this into your vector search database or a vector database, right? Now the second step is when a user says, what red shirts would I like, it's going to push that query, also convert into an embedding, and make a similarity saying that this is my query, what in my data set matches this query, right? And that is what vector search helps you with, where it's taking a input embedding and finding a similar embedding in our vector space. Then it's going to return relevant results and pass it on to your LLM. So here we are basically eliminating the process for you to build the search space. Uh, and how in the backend is it being done is the concepts of cosine similarity, L2 distance, inner products, which we've learned back in school in maths, right? And the algorithm we're using here are ANNs, or approximate nearest neighbor, right? Which basically uh, takes the entire vector space and divides it into smaller multiple spaces, as you can see in the diagram, and then it identifies that, hey, what are similar vectors or embeddings in my data set. Now what you're doing in the backend is, while you're storing these embeddings, you're also mapping it to real world use cases, right? Let's say I have one red dress, and then I have one orange dress, and then I have another orange dress, right? So all of these are now converted into embeddings, and I will also say that this embedding is corresponding to the dress one, this embedding is to dress two, right? So that metadata is what I handle on the back end. But what's happening here is it's able to return to you the similar matching embeddings. And this is the two components we're using in our solution, right? The embeddings API and the vector search uh, sort of solution we have. So how does a RAG flow look like now for a Q&A system? Let's understand this in context of, let's say I'm building a HR bot, right, for my internal employees. What I'll do first is I'll have tons of HR documents, right? Policies in the company, employee benefits, employee expectations, finance related things, payment related, right? How is their pay slips going out? All of this data is part of lots of policies which I have in PDF files. What I'm going to do first is I'm going to ingest that data and parse it. So I'm going to divide it into chunks which make sense. It could be chunks which are already file based, or it could be chunks which, and there are multiple sort of approaches to do chunking, parsing as well, but that's probably going to take a lot of time to explain. So it's beyond the scope, but it's something you can go back and learn more about. But this chunking also actually affects your end product, right? But the idea is that I chunk all of this data, use embeddings API, create embeddings for it, and dump it into a vector database. So now I've created a search space. Now in the retrieval or the data querying part, it's going to use this vector database to search the relevant chunk based on my input query and then send it to the LLM. So that is my flow now, end to end. So again, quick recap, I split my documents into even chunks or uneven chunks, if that makes more sense, and that's something you figure out based on your use case. You create an embedding for each chunk, you store the chunk in a vector database. When you're querying, you find the top case similar chunks from the vector database and you plug it in into your LLM response, right? Or your LLM prompt, sorry. Now, sample architecture, when we are looking at it on GCP or Google Cloud, uh, I mean, again, I've already covered this, but just for you to be able to visualize, what I'm doing is I'm taking my document corpus, pushing it into text embeddings API if you're building a sort of text based thing, and this could be multimodal as well when we go one step further. I'm creating that embedding and that context window in vector search, taking the user prompt, also creating an embedding for it, comparing it to my vector database, getting relevant data, passing it into Gemini, right? So these are the components. Vector search acts as your vector DB and your search space. Vector embeddings API, text embeddings API allows you to create these embeddings, and Gemini is an LLM model which you can use. Now, the idea is that based on your requirement, based on your use case, you're free to plug and play, right? So we're not saying that, hey, if you want to use vector search, you can't use any other embedding API. That's not the idea. The idea is that maybe you like another embedding API, maybe you already have embeddings, right? Plug that in into vector search. So it's a plug and play sort of architecture, and based on your requirement, you can see what works best for you. Now, another thing to sort of cover, which is relevant, is uh, do I build it from scratch? Because in this also, it's not an end-to-end solution, right? Where you're uploading your documents, you're getting a search engine. You are doing some parts of parsing, chunking, embedding. What vector search is solving for you is the indexing or the storage of the vector and creating that search space. So this is a more like a DIY RAG solution, right? Yeah. So while our labs will now make you familiarize with this, once you understand this, you can also look at out of the box solutions which we have. uh, why would you want to consider that? Let's say you're looking at the chunking phase, right? I'm not sure how to chunk, right? To ensure that my context is maintained, my data is consistent, all of that. Second step in terms of embedding, how do I pick the right embedding model? How do I tune the right embedding, right? These are questions I will ask when I'm building the solution this way. When I'm looking at also deciding what my vector DB will be, I need to understand what database to pick. Is it self managed? What sort of similarity metric should I use, right? L2 distance, cosine similarity. So it becomes a bit difficult for me to understand what do I actually use. What we have to sort of eliminate all of this turmoil is Vertex AI search. Now, just keep note of the names. The previous product was called vector search, where we're creating a vector space or an embedding space to search within. And now we have Vertex AI search, which is an end-to-end search engine which we are creating. So what is getting handled for you? Parsing, chunking, embedding creation, storage of the embedding, summarization of the actual output. So With this solution, you're not plugging into Gemini as well. End to end sort of workflow is built out of the box for you. So based on your team's expertise, based on the amount of control you want to have, you can opt between the two options. What you can also do is you can prototype using AI search, for example, Vertex AI search. And once you feel like, hey, I think this data works for me, you can easily also go back to a DIY model if you want more control. Those are a few things, right? Here you're handling a lot of components on your own. Here it's sort of becoming handled for you. So based on your requirement, you can opt for one or the other. Now, common use cases before we jump into having a look at what the labs cover and what that looks like. Common use cases here are question answering models. So let's say I have a lot of FAQ documents or the HR document example I gave. Let's say I want to build a chatbot for HR, right? A question and answer sort of chatbot for my internal users. How do I do that? How you would do this is basically create a RAG system for it and then create a chatbot on top of that, right? Similarly, again, obviously for chatbots itself, and also an agentic solution where you're trying to get uh, a sort of automated reasoning or decision engine, and the uh, answer for the user input is decided based on backend data which you have in your data corpus. So these are some common use cases. A lot of companies, I mean, some examples I can give in the industry would be one, a retail search, where you're creating a search for your product catalog. It becomes very useful there. Let's say you're building a chat bot for your HR, for your internal employees. So let's say someone has to look for travel policy, right? Hey, how do I apply for a 20-day leave, which is not a normal leave? So I want to understand the process. Now, instead of them having to find internal sources, figure it all out, it's going to find the relevant PDF which has details about the travel policy for employees, and then actually uh, um, return that as part of the response, right? So these kind of use cases become very useful. Even in the edtech space, there's a lot of potential for a RAG like solution, because you can build automated quizzes for your students and all of those sort of use cases, right? So these are more domain specific sort of use cases. In concepts like research, right? If I'm trying to build a sort of research agent where you're trying to quickly look for a lot of data from a data corpus. So the concept of indexing data goes beyond simple use cases, right? Even to build a coding assistant, right? You would want to be able to index your code base. And like we said before, right, in a multimodal model like Gemini, we're able to index code as well. Create those indexes for your data and actually run a search over it, right? Which makes it easy for you to actually uh, help your LMs use this data to actually solution something. So now we'll go into the labs. There are 4 labs. First lab covering Gemini multimodal use cases. Second lab covering retail recommendation, which is the use case I sort of doubled down on, which is how do I recommend items to my end user based on reference images. Third is a multimodal RAG solution, which is end to end what I spoke about, right? Creating the embeddings, storing it in vector store, uh, pushing relevant data to Gemini, asking Gemini to answer my question, right? So that end to end flow is sort of getting covered in this lab. In the last lab, you will have to uh, do a similar solution on your own. You won't have the steps defined, but because you're going to do the first 3 labs, you will be able to very well understand what the solution looks like, right? And what the different components of these solutions are. So, first lab, you'll completely understand how multimodality works. Second lab, you will understand how do we actually uh, take one reference image, compare it to other reference images, and do that comparison, and how Gemini does that well. Third is when I have too much of that similar sort of reference images I want to search from, then how do I build a RAG solution on top of it, right? So something along those lines. So just going into the lab interface, this is the 4 labs you have, which is part of your skill badge. First one being multimodality with Gemini. I think my screen is stuck, but these are the 4 labs, and they have sort of sub steps in them. Yeah, I think it's loaded now. So yeah, multimodality with Gemini, it has one specific notebook which you will actually cover. So let me open that notebook up on GitHub, because I have not started the lab in the lab environment. But just to give you a sense of what we are covering here is, we are going to be using Gemini 2.0 Flash. In the objectives of this particular lab would be that, one, you understand how to process and generate text. So starting from the basics, right? How do I give a text input? How do I get a text output? Second is, how do I understand and parse PDF documents? So you're going to plug in a PDF document as input and ask a question, or try to summarize that PDF document, right? Third is, how do I reason across multiple images? So if I have multiple images as input, how do I create or create an understanding or compare these different sort of images? Then we are going into video description generation, combining video data with external data, understanding audio, analyzing a code base, combining multiple of these modalities so we understand how a multimodal system works. Then we go into the use case of recommendation based on user preference, understanding charts and diagrams. So if you are looking at a, let's say there's an earnings report, right, a financial document of your organization, uh, the finance team is trying to understand that what were our earnings, how did our revenue look like over the few months. So in that case, they might have to understand different diagrams, different charts, and sort of make an understanding on top of it, right? Or let's say your data analytics team has created a dashboard. While the dashboard is good, because you don't have an understanding of the data, you're not still able to understand it. So let's say I want to build a chatbot on top of your dashboards, right? So in that case, it needs to be able to understand charts and diagrams. So how do we do that also gets sort of clarified in this lab. And then we sort of look at different images as well, and how do we compare them, right? So just to give you a brief, and I mean, I won't go over all the steps for all labs, but just to give you an understanding of how a lab looks like. First, we'll start with installing the relevant SDK, authenticating your notebook environment. You're going to use Collab here, Collab notebooks, or the OSS version being Jupyter notebooks, right, which is a very familiar tool. Most developers who are interested in AI ML have already used. So that is the interface you are working with. You import the relevant libraries, and then what you're going to do is you're going to actually start performing each of these actions, right? So how does a call to Gemini actually look like? You create a prompt, you make a content. So the content has your question itself and your prompt, and then you pass it to the model, right? And we have defined the model on top as Gemini 2.0 Flash. So you'll see this content can actually pick up anything, right? So when I have a PDF file, I'll make we use something called part to define a multimodal object uh, to be able to pass to LLMs. So here we are creating a part from a file, a PDF file, and then we're passing that into the contents, right? So your end call to the LLM looks just like this. Based on your data, you create a content. Here I'm saying that it's a file type, right? Application PDF. So you're able to actually push in different types of things. Here we're going to pass in images instead, right? Where we're passing in images into the model. So this is how the first lab looks like, where we're covering a lot of sort of use cases which are multi specific. Second lab would actually go into the concept of, how do I build a solution which is able to understand retail related use case, right? So in the second lab, what we're going to do is, we're not going into a RAG solution yet. We're going to take a reference image of, let's say, a living room, right? That's the example which is there in the lab. We take a reference image of a living room, and we say that I have these four chairs. What do you think best matches my living room, right? More from a interior design perspective. But that is the use case we'll cover, where we'll take a bunch of images and we'll compare them to each other and understand how does multimodality work to create recommendations, right? So if you can see here, the use case which I just defined, which is very specific to the retail industry, but you can actually go out and do this for any recommendation you would want to build, right? Where I have a customer, a photo which is being passed, and then you have four options, and you're trying to help them understand what is best used. Now, while this specifically might not be a use case relevant to you, the idea is to spark the thought process in you to be able to build systems like this or solutions like this, right? So this is what it's going to cover in the lab, where you will understand how to use Gemini model for visual understanding. You'll take multimodality into consideration when you're prompting. So here it actually, in the prompt itself, you'll see how we have tried to incorporate and sort of make the model understand that, hey, I want you to understand, or make a understanding on these particular images, right? So here we're passing that, consider the following chairs, and then we've labeled each of these chairs, and we're saying that you're an interior designer. For each chair, explain whether it would be appropriate for the style of the room. So we are crafting prompts based on our use case in this case, right? Similar use cases would be recommending clothes based on the occasion, or recommending a wallpaper based on the room and setting, right? These are just some examples, but this is what the lab will cover. Now the last lab, and this is a long lab, it's very interesting. Like the first time I did it, I really actually enjoyed it, because it's covering your end-to-end process, right? So the diagram I had showed initially, let me pull that up. This diagram, you're actually implementing this end to end, right? And that will give you a good idea of each of the components, and you can actually use any of these components later in your use case, right? So definitely recommend everyone to go through this lab, do it in detail, and uh, try to complete it, right? Because it'll give you a lot of learning. So what we're doing in this lab, if you can see my screen here, is that we're building an end-to-end RAG solution, and we're building it for both textual sort of understanding and multimodal RAG as well, right? Where we're looking at both processing text and visual information. So what we're going to be using here is, we're going to use Gemini obviously as our LLM. We're going to use our text embedding models, and we're also going to use our multimodal embedding models to build a document search engine, right? So you will get an idea of how to I build a multimedia rich metadata repository. Now, just to double down on this, while I covered it in brief, why do you build a metadata? Let's say I am passing, and vector search is dealing with only embeddings, right, which are vectors or mathematical representations. So I'm taking my user query, converting it to an embedding. I have embeddings of all of my documents from my data corpus. I say that, hey, user query is matching document A, right? Or embedding A, sorry. Now, how do I correlate embedding A to document A? That's why we're building a metadata, right? And that's going to get covered as well, where your metadata will have document sources, which will basically enable that search and comparison, right? So what are your objectives in this lab? You're going to extract and store the metadata of documents containing both text and images, and generate the embeddings for them. You're going to search the metadata with text queries to find similar texts or images. So what we're doing in this case is, we're storing all of these embeddings in our vector database, and we're doing a search, right? And the good part is that when you have new documents, your only work is to create embeddings of that and push it into the same vector database. First, we'll do this with text, and then we'll do it with image queries, where we'll send an image, and then we'll find similar images. And then what we'll do is, we will actually another additional step which really helps in these kind of solution is, for the images as well, we use Gemini to create descriptions, visual descriptions, and create embeddings of that as well, right? So it's making the data a lot more rich. I have a very rich data corpus of embeddings which I can search within. So again, in this, you're going to cover all of these steps of understanding the different models we're using. Again, we're using Gemini 2.0 Flash, which is multimodal. We are going to run through this entire data source, right? So in this, it's again covering that use case which I spoke about, which is the company's financial performance. So in this lab, this is sort of the data, and this is a very small example, but the idea is that you're still going to understand, right? So what we are going to do is, we're going to create chunks out of this, and we're going to this is a very uh, it's a 100-page document, but it's very rich, right? It has charts, it has graphs, and it has a lot of data which is numerical, a lot of numbers. It's quite rich, right? So we're going to use this data to actually understand how do we work with multimodal systems. Just let me load the screen. Yeah. So, like I said, we'll build the embeddings for this, store the metadata, and actually start looking at uh, querying this data because of that, right? So, some helper functions which we'll do here is, we'll get similar text from query. This is finding similar text embeddings. Then we are also going to be able to find the citations. Why are we going to be able to do that is, uh, what we're doing here is we're comparing two embeddings, returning relevant embeddings, and then these relevant embeddings are also going to say that when I'm answering my user query using the LLM, where am I getting the data from, right? What is my citation? So all of these steps are going to get covered in this lab. So that is the fourth lab. I think that's the first three labs. And when you do these three labs, you'll get a good sense of how do I approach my last lab, which is your challenge lab. Here you won't have instructions per se, step by step, but you will still be able to do an end to end of how do I work with sort of these rich documents and create the metadata and get all the relevant text search using my RAG system, right? So that is what I had to cover today. We will go back now to the screen and just see if there are any questions which are there in the chat. Okay, I'm just trying to find the questions. There are a lot, but let me pick up a few. Um, so, so yeah, when we talk about building our own RAG system, this is a question from Syed. When we talk about building our own RAG system versus something like Vertex AI's managed search, how much customization do we really need? So the best way to find this out actually is first use the managed solution because it's very easy, right? Your task is just upload your documents, it's going to create the index, you're going to get the results. You get very few tweaks here. You can decide how it's going to rank, how it's going to filter, what model is going to use, of course. These are some customization you are allowed in a managed solution. See how it's working, see it in a real life use case, try out a few queries. If you feel like the response is not good enough, then you say that, hey, makes sense. Maybe I need to customize a little more, right? Maybe my chunking is not happening in the way I want. Maybe this managed solution is not understanding my data very well, and because of that, is not chunking it very well. Maybe the embedding model which is being used is not maybe what I want to use, right? So when you start feeling like your query results are not good, that's when you go back into thinking of a DIY system. Always the approach is try to use something which is easy. For example, Gemini, right? We could do OCR before with a OCR model, right? Which is you have to create an OCR model and then try it out. But now when a customer comes to me or someone comes to me with a use case for OCR, I say, hey, try Gemini out first. If you're not getting the right amount of control and you want to build something custom, that's when you go into a custom solution. So that's the idea. Let me just, there are a lot of extra points as well, uh, which I want to look at. Uh, so, is there a file? Is there any file format constraint for diagrams? A multimodal model like Gemini understands images. So that could be all image formats, PNG, JPG, all of those. It also understands, so when you're looking at PDFs, for example, which have images in them, there are two ways to do it. It will either treat an image, it'll treat a PDF page as an image, or you can, if you want to sort of extract out images from your PDFs, you can do that and still pass it on. But in terms of file format constraint for an image, there is no challenge. Any image format should be able to, JPG, PNG, the common ones, right, are acceptable for this sort of use case. Um and some more, I think people have tried it out with BigQuery and it's worked for them. There's one important question I want to address it, which is, can RAG really be a replacement, right? Which is Radhika's question. And this is something which is very commonly a term which is used or a sentence which is used in the industry. RAG is a very, very sophisticated hack which we've built, right? It's a very, it's in Indian terms, it's a jugaad we've done, right? What are we actually doing? We're going to, it's like a, let's say you have an exam, right? If you're, if I wouldn't recommend it, but if you're trying to cheat, if you write all the notes in your hand, that's going to cover your entire hand, right? But if you're smart enough and you say that if I just copy the formulas, that's maybe going to be helpful. So that's what RAG is, right? We're just going to try to get the relevant information. And why are we doing this hack in the first place? We're doing it because our models right now are not able to take a lot of context, right? I can't pass 200. I mean, sorry, 200 I can, but I can't pass 2000 or 20,000 or 2 million PDF files into my prompt, right? So that is why we are using RAG. As our models become better, as our compute becomes stronger, if it's able to handle larger context windows, we are going to, RAG is not going to be helpful there, right? Because then I'll directly pass everything. But why RAG is so important is, today, if I pass a lot of things to my ML models, and this is across LLMs, right? I'm not just talking about our LLMs models, across industry, sort of open source or models like Gemini. If you pass too much data and you give it a lot of information, uh, it is going to it's going to be bound to get confused, right? So why not instead pass what is relevant to it, uh, uh, which is why we are using RAG as a solution, right? Uh, that is sort of solution. So I think, yeah, there was a discussion on the chat as well in terms of it is a hack, but the idea is that you need to finesse the back end of it, right? If you really get your chunking right, if you get your embedding right, if you understand, and that's why when you, as an ML engineer, you would maybe not want to use vertex search, right? You want to control each of those elements, and that's why we go into a DIY approach where you want to understand the math behind it. So in those cases, it is very important to understand what is happening in the back end. Um, can you suggest a workflow that can customize the agentic RAG with an MCP? So MCP is a protocol which is basically letting you connect to any system, right? So the idea behind MCP is, when I'm using an LLM and uh, X company has a solution, Y company has a solution, they want to expose this data to you. For them to be able to make it standardized, we're using something called Model Context Protocol, which is MCP. So if you are building a RAG solution, what you would do is to expose it for any LLM, right? Let's say I'm using Claude today. Tomorrow I'm using Gemini. Tomorrow I want to switch it to Mistral, right? Or any model. If I want to keep ensure that across different models, my RAG solution is capable of communicating with these different models, irrespective of what input format they expect. That's where MCP comes in, right? So yes, the workflow would basically be that you still build your solution, you build a MCP server on top of it, and then any end solution can use it as an MCP client. So like you would build any sort of MCP solution. So that's how it goes. So your RAG system sits behind that, basically. Um, just curious, will we be able to see the output? We have around 6, 7 more minutes, so we'll take a few more questions. Ganesh, just a quick check. Is there anything else you want to cover for which I should leave some time?
No, no, you can definitely take any questions.
All right. Okay. So, a question which is there in the chat is, will I be able to see the output from the vector databases before I pass it to the LLM? Yes. So, vector search, what it's doing is it's taking an input, embedding as input, and is giving you, and that you can control the number. But let's say it's giving you 10 similar embeddings, right, with a relevance score. So now you can say that I don't need all 10. I'm going to pass the first three based on their relevancy score, which is where you do the ranking, and you pass it to the LLM. So yes, you can see it because these are still two separate systems, and that's the good part about it, right? Which is why I said it's a plug and play sort of solution where you can decide what components. So yes, you're able to see it. You can decide how to use it. A big use of being able to see these chunks is citations, because when I know what chunk my answer is coming from, I can say that, uh, hey, this is the answer to your question, but if you want more proof, not proof, but if you want more understanding, look at this data source, right? So that's the idea. But yes, you can do it. Can it work with ERP data? Yes, it can work with. Uh, the idea is that a lot of these solutions, not a lot, all of these solutions, which I at least discuss, are API based, right? So as long as you're able to pull in your data, relevant data, and plug it in, you can orchestrate it, right? Uh, the idea now with every solution you'll see with any sort of tech company is building, the idea is to make it convenient to use, right? So very API friendly. We have Python SDKs, all of that, so you can um, sort of use it that way. Can someone who's not a developer, not worked with Python, use this? Largely, yes, I would say. You can use it as well. Um, the good part is that these labs do have a lot of comments, so you will be able to understand. Uh, uh, Another pro tip would be that if you're looking for anything to understand more, go into YouTube and type the same thing, right? Like just say MCP and then go to YouTube. When you see a video, it becomes a lot more clear to understand. And then when you come back and look at the code, it's going to be a lot more simpler. With LLMs specifically, to use LLMs, you don't need to be a developer. You're passing a prompt, which is English. The best part is you can use Gemini to write your prompt itself. So you can say your use case and going to write your prompt for you. So that also becomes easier. So no, you don't need to necessarily know coding in depth. A basic understanding always helps, but you can still do the labs for sure without it. At least very, and the core basics which you need, you might be able to understand with the comments in the lab itself. Uh, I think I'm not able to spot more questions. I think a few of you have been talking as well. One last question which I can see is RAG use does RAG use function calling internally? Function calling is a separate sort of capability of Gemini. What does function calling actually do? It is uh, at the LLM, because of its capabilities and because of its understanding of natural language. What it does is if I've given 3 4 different tools to it, which could be, one is a get current weather, what one is get current time, one could be get the latest data about this user, the last order, right? These are different functions. So the LLM has an understanding that, hey, based on this query, I need to call this function. So function is a piece of code you're executing, right? So that is different. RAG is the idea is still that you're connecting it to backend sort of action which is happening, but here you're searching for some data, whereas in function calling you're executing some data, right? You're running a function. So that is the difference. So no, it's not using function calling in the backend, but it is actually uh, these are two separate systems, right? It's finding relevant data and then plugging it into your prompt itself. Do I need to understand transformers and LangChains deeply to master GenAI and RAG? To understand the concept behind it, yes. To use the products, not so much. To use the LLM model, you don't need to necessarily understand the backend. But as someone from the tech, if you're looking at it from enhancing your tech skills, it's always recommended to go back to the basics, because it will make you appreciate it a lot more and understand it a lot more, right? Uh, can we use GenAI APIs as an AI agent to perform a specific task? So, just to give you a sense, an AI agent, an LLM is just one part of an AI agent. An AI agent as a whole, I wish I could pull a diagram up for you. Give me 1 second. Right? So, an AI agent is not just your LLM model, but it's also the tools it's working with, or the sort of information pieces it's plugging in, right? So, if I look at this tab, this is something an AI agent is, right? An AI agent will use your LLM models, which is Gemini APIs. It will also, along with it, have a instruction set, which is your agent definition. It will connect with your tools, which are your function, which is function calling, your APIs, your databases. You could have a RAG solution. So a RAG solution, what would a RAG solution be? It would be a tool, right? Where while I have my agent will use a RAG tool to get some information and pass it to my LLM model, right? So that is the way we can think about an uh, AI agent. So that is what an AI agent is. I think we're on time, but I think really good questions. I hope this. I'm sorry if I couldn't answer some of them. I tried to spot most of them. I hope this was helpful. If you have a lot more questions, I would say that just look for these terms online, RAG being one. We also have articles on our cloud pages. So that will really help you understand a lot more. And then you can take it up from there. But first step would be to do these labs. That will in itself clarify a lot of things for you, because while you hear someone talk, it doesn't always make sense. But when you do it on your own, it will be a lot clearer. So first step, do the labs and then start doing your reading, right? Go into YouTube, go into our documentation, go into open source documentation, right? Understand these concepts, and then you'll be able to choose, right? Is Gemini the best model for me? Is uh, DIY better for me? So that will work out that way. uh, yeah, I think that's it from my end.
Yes, thank you so much, Sanskrit, for walking through the lab. It was a really interesting session. And I can see participants still have a lot of FAQs with them, and we would need to take another session for this FAQs alone. But
Yeah,
as Sanskrit did, always go to the lab first. This was a nice tip from her. Just go to the lab first. If you have something, then go to the YouTube and documentation, rather than jumping into YouTube and documentation and then going to the lab. Just try first and just look for the answers for the questions. And with that, if you have any questions after this, please do write to the support email. And I'm sure you must have received a form throughout the session. You can fill that form as well. And if you still have any questions regarding the points, leaderboard, anything about the program, you're always free to write to the support email alias, which the email drop right now. And you can always find this in the dashboard as well. And thank you so much for having session over here. Thank you so much, Sanskriti.
thank you so much.